All right, Chapter 5, the Unified Facility Control criteria, operational practice, operational maintenance of the petroleum system. Chapter 5, Hydrant Fueling System Type 2 Pritchard. General information Type 2 Pritchard was developed in 1955 to improve operational characteristics of all convenient and hydrating fueling system and it can serve as multiple hydrant outlets per control pit and allow more flexibility in parking aircraft, reducing need for the tow aircraft to the refueling position. Type 2 pump houses is similar to Type 1 except that the separate defuel tank is no longer needed. Instead of one Type 2 operating tank is designated as the defueling tank for the day, and the fill meter of the Panero system is now laterally controlled, or the LCP lateral control pit and defueling pump with the 4 different automatic valves has replaced the dual purpose 302 AF valve. The military housing 2 or hose cart is standard equipment in connection with the hydrant outlet of the aircraft. There is no need for filterization meters in the liquid lateral control pit. Figures 5.1 show the layout of the typical system following the simplified description of operation. 5.1.1 refueling. Like the Type 1 system, when refueling is required, the hydrant outlet operator places a magnetic on the refueling magnetic control system KISS switches that causes the pre-selected pump in the pump house to start energizing the solenoid and refueling the control valve 90 AFA 8 and the hydrant lateral control pit. The fuel moves to the pump house and the fuel manifold to the lateral control pit enters the refueling control valve and causing it to open. The 95 AF8 valve provides 5 functions: produce pressure reduction, non-surge pressure relief, excessive flow, shut off, emergency shut off, fuel flows thoroughly hydrant adapted to the military hosing to core cart of the aircraft during refueling. The 134 AF defueling valve solenoid is de-energized with the valve and head held closed at the 50 AF2 pressure. The relief valve excess pressure the upstream the 95 AF8 into the defuel line. As you can see now, the fuel line and the defueling headliner go in the opposite direction and the other way, making it a complete block. Alright, defueling. When it is necessary to evacuate the house cart, defuel the aircraft, the operator places the magnet in the defueling KISS switch that causes the solenoid of 134 AF defueling valve to open. The defuel pump is energized. Fuel is then drawn through the defuel pump, forced into the 41 AF rate of flow control valve. The defueling line at the rate of the 757 liters per minute or 200 gallons per minute. The fuel flows from the operating tank designed to receive the product. 5.2 deep well vertical turbine pump. The pump is designed the same both for Type 1, Type 2 hydrant systems. See Chapter 3 for the description, Chapter 10 for the maintenance of the frequency. 5.3 the non-serve check valve. The 81 AF that has been converted to the AF 81 AF8 non-serve check valve. The figure 852. This modification involves replacing the swing check valve with the hydro check valve. The speed control setting are the same, described in the Type 1 Panero system 4422. This is the non-surge check valve of the 81 AF8. At the top, you see the CF control valve openings. 8101 check valve, 8101 check valve, the outlet and the main valve body, inlet and outlet. Filter separator. Chapter 3 gives the description of a typical field separator. Chapter 10 outlines the maintenance of the frequency. The field separator control valve with the FSCV 40AF2C. The 40AF2A field separator. Filter separator control valve has been modified at the most of the base. The new valve known as the 40 AF2C figure 55.3. The 40 AFC2C valve still performs the same of the function of the 40 AF2A. Control the rate of flow through the separator, prevents the reverse flows to prevent water discharge when the flange flow controls reach the highest position, but not in the high troll ejector. And see the figure 143 would replace with the 102B13 weighted high troll with the 3.1 millimeter orifice. 5.5 valve setting. They set the rate of the flow of the control of the discharge 600 gallons per minute using the CDSH2B, turning the adjusting stem the clockwise, increasing the flow rate, and counterclockwise to decrease. Alright, this is a filter separator control valve with the remote control line going into the low and high point of the A, B, and C three-way control valve, also connected through the CDSH differential control into the main valve body on its inlet and outlet orifice plate with a VPI. The refueling control valve, the 90AF8, generally the 90AF8 is a combination between pressure reducing emergency shutoff, non-surge pressure relief, and excessive flow shutoff valve. This is the refueling control valve, 90AF8, pressure relief control rotary disc, a pressure differential control, a reset button, and orifice plate, a flow for the clean strainer, line 1, 2, 3, 4, and 5, a VPI, which checks the pressure, hydro valve, A, flow control, solenoid control valve, ejector, pressure reducing control, and hydro valve B. Flow cleaner strainer also was on the bottom. 562 pressure setting in the CDR accompanying the normal operation pressure of the 100 psi furthest outlet. Notice the normal operating pressure is the lowest pressure and capable of achieving maximum flow at the rate of smooth operation. Set the CRL to close the refueling control valve at 5 psi above the normal operating pressure. Set the CDSH3 according to the procedure attachment 3. Set the CV control flow control to open the valve as quickly as possible without tripping the CDSH3. 5.7 pressure relief valve, the 50AF general pressure relief at the figure 5.5 is installed with the hydrant and the LCP between the refueling pipeline and defueling line. Pressure relief valves are provided with the relief of excessive pressure caused by closing downstream valve with the thermal expansion into the closed section of the pipeline. The valve is installed in the flow fuel under the disc and so that it fails safe in the open position main valve diaphragm fails. This shows the pressure relief valve with the strainer orifice, the CRL pressure relief valve, the inlet side with the refueling manifold at 90 AF8, and through the main valve body through to the outlet side of the defueling line. 572 pressure setting. The 50 AF2 should be set at 10 psi above the normal inlet pressure to the 95 AF. Typical settings are ranged from 110 to 125 psi. Recommended setting procedure: the refueling control 95 AF8 measure relief valve. The 50 AF2 set up the system. The valve refuel through the 90 AF8 valve. Ensure the gauge is installed with the part of this hydrant outline. Be sure the CDSH3 is cocked position both of the CRLs 90 AF8 and 50 AF2. Energizing the system establishes smooth flow. Adjust the 90 AF8 and the CDR until the gauge of this outlet reads 105 psi. Back of the 95 AF8 CRL using the gauge needle pit dips 2 to 3 psi acceptable. Adjust the 90 AF8 CDR until the gauge's outlet reads the 100 psi. Notes the 90 AF8 inlet pressure to de-energize the system. Closed manual valve downstream in the normal AF8 shuts out normal 90 AF8 solenoid switch, energizing the system. Back off the 50 AF8 AF2 CRL. Set screws of valve starting opening inlet pressure of 90 psi or at 10 psi above normal inlet pressure recorded in figure 578-38. De-energizing the system, operating the manual valve with the turning of the solenoid switch, figure 5732 57310. Or the 5.8 defueling control valve, or the 134 AF. The defueling control valve of the diaphragm is an actuated cylinder shut off. The valve is defueling pump to the energized simultaneously. When the valve is energized, it opens a permanent defueling through the system. Figure 5.6 shows the defueling control valve 134 AF, but the ejector de-energizer closed on a circuit to the inlet and outlet portions, while the ejector goes through the top of the main valve credited. The dual rate of the flow control valve 41 AF. The dual rate of the flow control valve, figure 5.7, the combination rate of flow of the control valve, the fastest closing hydraulic operated check valve that closes the main valve that against the reverse flow. It performs two distinct functions: maintaining a preset flow of the 757 liters per minute or 200 gallons per minute, acting as a check valve to prevent the reverse flow. Pressure setting set the valve maintaining a flow of 757 minutes per liter or 200 gallons per minute according to the manufacturer guidelines. The dual rate flow control shows starting at the inlet side from pump up through the inlet side out from the out pump, the defueling into the hydro check valve, the ejector, and the top of the control valve. Top of the the main body of the valve to the differential control of a 200 gallons of CDSH open back into the flapper type of the check valve and the top of the head of the main valve body, and also back to the outlet pump, and also with the differential control CDSH open the outlet side of the defueling line orifice plate. 510 recommended setting procedure for the rate of flow of the control valve 41 AF with no pressure on the system backup. The CDHS2 stopping as soon as the string session is lost. Turning adjusting screws clockwise to complete the turns and getting the lowest rate of the flow. Setting with the CDHS2. Never to apply the CDSH to the adjusting screw less than 2 turns setting. 3. Set up the system to defuel through the 41AF. 4. Place the magnet on the defuel kiss switch. 5. Turn the CDSH stem clockwise until you get the flow of 200 gallons per minute. 6. Remove the magnet from the kiss switch. 7. Return the system to the original condition. Also, 511 defueling. The defueling pump is initiated by the hydrant lateral control port using the pump of the fuel for the aircraft designated defuel pump tank pump house. The defuel switching in the hydrant outlet control the pump. The self-priming central defueling pump. Figure 5.8 differs standard central figure pump because the vane type of the suction pump is mounted on the pump shaft, which the main pump discharges pressure and is below 10 psi. Priming of the pump of the primary position 5.9. It draws the suction side of the pump discharge to the point of the downstream check of the valve so the primary central figural. When the main pump discharge reaches 10 psi, the priming pump moves to the normal position. Figure 5.8 self-priming central figural defueling pump. Primary pump discharge line, built-in check valve, improper impeller. The suction inlet vapors and outlet openings through the valvet casting, mechanical sealed end ball bearings, priming the motor pump, and variable replacement rotor block. This shows the primary pump discharge line through the liquid line and a primary discharge line for the air vapor. The figure 5.9 central figure priming pumping operation. Full priming with the air vapor in the lines. Pressure of the spring on the top of the removable slide holds the primary pump in the full priming pump position. Partial priming. The primary activates as the pump evacuates the air. The vapor from the lines of liquid pressure builds up inside the underside of the slide and moving upward and toward the neutral. Neutral is when all air and vapor are removed. Liquid pressure equalizes the springs measures and the pump automatically slides into neutral, where it stays until the air and vapor again appear in the system. 512 remote controls, electrical and magnetic. Remote control fueling and defueling emergency stop is performed by 3-element magnetic control switch, kiss switch, located near each of the hydrant pit. The magnet controls each of the 3 functions, placing the horseshoe magnet on either the refueling defueling kiss switch, causing the appropriate pump to be energized. Usually a lanyard is attached to the magnetic quick revolve removal of the magnet is covered the emergency stop with the holes of the switch closed. By lifting the cover of the switch deactivated with the system shut down, spring loaded, and the covers of the refuel defueling switch must maybe be removed. 513 hydrant adapter liquid control and valve 352 AF at 352 AF figure 10 provides a quick pressure tight connection with the M2 hose carts of the 351 AF moose head 352 AF as a float assembly that controls the level of the fuel maintaining the piping at the end of the defueling. The float keeps the air from entering the system. Here is your typical hydrant adapter. From the left you'll see a stop and jet fuel push button stop at the AV gas. From the disc assembly, an O-ring bypass valve going into the gaskets with other gaskets, and from the top you'll see a seated gasket disc, seated poppet, cover upper body and lower body, and gasket to the hydrant with a gasket and float disc on the bottom side of the hydrant. During the fuel operation, 352 float assembly is lifted in its seats from the float chambers, fills with the fuel opening valve, and at the end of the defueling operation, the float chamber, the drains of the float drops to the closest valve, preventing air entering the system. A replacement poppet and kit is available with the cloud valve 352 AF. The hydrant adapter. The kit must be installed on all adapters to preclude sticking problem encountered with the original puppet, with the puppet face with stamped on the Mod 1 and kit is installed. 5.13.4, the API 364 AF2 hydrogen adapter is mating the mount Moosehead industrial standard replacement of the hydrogen adapter 352 AF and 351 AF Moosehead. Replacing the older adapters must be joint economical decision between the basic contracting, basic core engineering and refueling, maintenance and hydration of the M2H2 hose carts are modified at the same time. 5.14 hydrant hose cart. The MH2 hose cart contains a filter separator. Meter maintenance of the hose carts is responsible for refueling the maintenance. The high-level shutoff, the HLSO high-level shutoff, the 124 AF has been upgraded to 129 AF figure 511 by installing an injector ball float assembly. The setting is being set as the Type 1 system is 279 millimeters or 11 inches from the top of the tank. See Chapter 10 for maintenance frequencies. Also, you see from the ejector of the main of the float of the valve into the tank from the pilot valve opening with the float assembly. 5.16 type of the 2 modified rapid flow. The rapid flow modification was done at the basis to increase the deflow rates of the 200-300 gallons per minute to speed turnaround of the KC-135 and other larger aircraft. The pump of the aircraft flows from the aircraft through the lateral control point and into the designated defuel tank. The hydropower of the pump complies with the operating engine and idle speeding, and the defueling pump into the lateral control point is only used to evacuate the hose of the cart and after the aircraft is de-energized. Oh, I'm looking. 5.16.11 combination dual rate of the flow control solenoid shut-off check valve. The valve operates the same as 41 AF when the addition of the solenoid remote control operations. All setting functions are the same as 41 AF. Combination dual rate of flow, the control valve, solenoid valve. The inlet side from the defuel pump outlet goes in the hydro check valve ejector, which goes back into the top of the main valve of the body while the valve is closed. And also to the differential control. Differential control is open and the ejector goes through the second port solenoid closed flapper type check valve, which turns up and down the pressure. The differential control LP, the gallon pump for the pump, it goes down to the outside side of the defuel line, be closed in an orifice plate. 5.16 combination dual pressure relief. The solenoid shut-off valve the dual pressure relief is installed with the modified with the hydrant control pit. Downstream refueling control valve between the hydrolateral pit line, defueling line by passing around the defuel pump is shown in Figure 511. The refuel valve to perform the 2 functions: relieves excessive pressure of the hydrant lateral pipe caused by the quick closing of valves during the refueling operation, maintains a minimum pressure of 5 psi hydrant lateral piping. When refueling the pump and not in operation, the valve also the CV flow control to slowly close the valve during the during operations. Alright, a dual pressure release solenoid shut-off check valve. On the outer line, you have your line going from the inlet hydrant outlet to the high pressure CRL closed, and also into a low pressure CRL, and then back into the outlet defuel line to the swing check valve, while the other line goes to the hydrol check close 3-port solenoid A, B, and C ejector and CV flow valve into the main head, which is closed, and the outlet defuel line after the defuel of the pump. I have to say I've studied Navy valves in 6 credit course, and these are like way more complicated valves than this in that whole 6 credit college hour. Operation. During rapid fuel defueling operation, pressure supplied with the aircraft pumps will open the low pressure side of the 51 AF4, provided with the thermal relief of the hydrant level of the piping. While the refueling pump the solenoid is energized, locking out of the low pressure relief control, putting the valve underneath the command of the high pressure relief control. 5.16.2.3 pressure setting. When the refueling pumps are operating with a set high pressure CRL at the 5 psi of the 90 AF8 and CRL set point, when refueling the pumps are stopped and set low pressure CRL at 5 psi, adjust the CVL flow control closing the speed to provide with a smooth pulsation-free operation. Recommendation setting procedure for the combination dual pressure relief solenoid shut-off connection valve at the 51 AF4. The low pressure CRL are Setting. Place the magnet of refueling the kiss switch to pressurize the system. No hose, the cards are needed for the procedure. When the system pressure has been built up, refueling the control valve, the 90AF8, and has been closed, remove the magnified refueling kiss switch. The 51AF4 should be open. The system pressure should drop when the 51AF4 knows the pressure gauge reading. If the pressure is more than 5 psi, slowly turn the adjusting screw counterclockwise until the pressure drops 5 psi. If the pressure is less than 5 psi, turn the adjusting screw clockwise to raise the CRL setting. Then repressurize the system adjuster of the CV flow control speeds to provide with a smooth pulsation-free operation. Check the setting and starting with the stopping of the pump, checking the system and the pressure, 51632. High pressure CRL setting, set up the system dispensing fuel from the hose cart to the truck, bottom of the adjusting screw on the 51AF4, high pressure CRL, bottom of the adjusting screw, the 90AFA CRL, place the management of the kiss switch to the start of the deep well turbine pipe, slowly turn the 90AF8 CDR clockwise and pressure gauge in the pit of the read at the 5 psi on the normal setting of this 90 AF8, slowly returning the adjusting screw of the 51 AF high pressure CRL counterclockwise until the valve starts to open. Stop, start, and deep well pump to recheck the setting. Adjust the 90 AF8 CRD and 5 psi normal operating pressure. Adjust the 90 AF8 CDR counterclockwise until you get in 2 psi, 2 to 3 psi drop. And adjust the 90 AF8 CDR NOP normal operating pressure. Restore the system original condition. Alright, 516-3858 hydrant adapter to conduct the rapid defueling operation float assembly in the 35-2AFA valve to remove the 3.1 millimeter angle valve installed with the tap holding body. Hydrant adapter manually bleed off the vapor air and to prevent the air from entering the system. The hydrant is not used in the X73 aluminum blank cupping cap shown in figure 514 would replace the rubber dust cover. The maximum vacuum pressure was installed in the cap to dissipate the vacuum to adjust this other cap is removed. Modify the valve and closed with a 358 vacuum 358 hydrant adapter or X73 aluminum blanking capping with a vacuum breaker, testing opening retaining ball, sealing gasket, and rubber boot. Chapter 6, containing pressure, hydration, refueling system, type 3 Phyllis.